All right. So welcome to the first workshop of on security and privacy of next generation networks, FutureG. So I hope you have been enjoying the nice weather at San Diego. At least it's a great escape for me. I'm from Pennsylvania. It's snowing there. So yeah, welcome you all here. So on behalf of the program co-chairs, me and Professor Ji-Chiang Lin from Ohio State, we welcome you again. All right. Sorry about that. Oh, okay. All right. Great. So first of all, I would like to thank all the authors who actually submitted the papers to our workshop. And also, nothing goes short to our amazing program committees. We had 22 program committee members, and they relentlessly work for this workshop to make it a great success. So let's have a big round of applause for all of them. So just a quick statistics of the paper submission. We had 17 papers submitted. For out-of-scope papers and double-blind submission violations, we had to just reject 2 papers. And out of 15, we accepted 8 papers. Out of them, 3 were long papers and 5 were short papers. And again, 22 program committee members. Each paper was reviewed by 3 reviewers. And also the program committee members had a lot of comments, and they passionately argue about the papers, and that's why we have a great program today. So before I go to the agenda, let me hand over the microphone to our program co-chair, Ji-Chiang Lin.
So we didn't present you the geolocation of the authors. Actually, most of them are from the US. So only 2 papers from, one from Africa, was the other one I forgot.
One from India. And
India, right? Okay, yeah. So most of them from US.
and Europe.
So this is the program. We have just half day. Maybe next year we can have a full day. We will start with a panel, and then followed by AI assisted NextG, and then we'll have the keynote and another session on security analysis of NextG. Finally, novel threats in decentralized NextG and the secure Open RAN. We will conclude at 6 o'clock. Speaking of keynote, we have Young-Dae. So he will talk about the metasploits in cellular network. And panel will be moderated by Arup. So, fortunately, we have 3 good panelists here to share you about the security and privacy issue in both 5G and 6G. Again, thanks for all the authors and the program committee. Next, maybe we can get the panel started.
Yeah. So let me invite all the panelists and the moderator, Dr. Arup Bhuyan from Idaho National Lab, and Dr. Ted Woodward from DOD, OUSD, DOD, Dr. Donald, I forgot his last name, McBride, sorry about that, from Nokia Bell Labs, and also our Dr. Phillip from SRI. Please be here. Yeah, please sit down. Yeah.
So do you have to click this to advance?
Yeah.
Okay, got it. Yeah.
So just check whether the.
I can speak here, right?
Okay. Yeah, you can.
Yeah. Okay.
I can see her.
Yeah. So
Yeah, you can sit there, Phil.
Thank you.
I'll be spending most of the
just
time.
make sure you turn on the mic.
Okay.
Hey, thank you, both professors, the chairs. Thank you for having this panel. Hey, my name is Arup Bhuyan. I'm from Idaho National Laboratory. I'm a directorate fellow there and also director of Wireless Security Institute. And it's my pleasure I'm very excited to have our distinguished panelists. I'll introduce them in a bit. But this panel is on the security and privacy for issues in the advanced or new 5G capabilities, the latest one in release 17, 18, and so forth, and also the upcoming what will be 6G. Let me just say a few words about the INL's Wireless Security Institute, which focuses on making the advanced use of the advanced wireless technologies secure, particularly for mission-critical communications and its use in the critical infrastructure. So we got the three components. We have the research component, of course, within the lab, and also collaborating with various, mostly university researchers. Then we have our own unique wireless test bed, and this is in federal land of about, overall size is 890 square miles. So we operate with NTIA's experimental station status. We can operate out just like Verizon's or T-Mobile's. We have our own small private networks that are the standardized, and we work with commercial devices and conducts experiments over a lot of different frequencies. And then, of course, the third component is very important. We do collaborations with the government, industry, and academia on issues that are important for at the national level, the security issues. So with that, let me first introduce Dr. Ted Woodward. Okay, one, two first. As Professor Said said that, it's really, Dr. Ted Edward is the technical director for FutureG in OUSD Research and Engineering in DoD. He is also the research professor at the Applied Research Laboratory in Intelligence and Security in University of Maryland. And he focuses on connecting the advances or the new research in cellular and others, wireless now, particularly cellular, 5G and 6G, connecting them across the, for the end user's benefit across both the government and the commercial sectors. And so the next is Phillip Porras, who is the program director of the Internet Security Research in the Computer Science Laboratory in SRI, and a research as a fellow, SRI fellow. Phil is also the co-founder and is chief scientist of Equinox. And he has close to 100 published papers, peer-reviewed published papers, and 33 patents. So, and then our Don McBride, who is senior security researcher in Nokia Bell Laboratories, the famed Bell Laboratories in Nokia, which is now in Nokia. And right. And I started my career in Bell Laboratories, so it's always a fun place. So anyway, Don focuses on security and risk management solutions of course, to realize secure and reliable wireless networks. So please give me a hand, let's give him the panelists a hand to welcome them. Okay. Let me take another couple of minutes, and then the format of this panel is that all of our panelists will speak for about 10 minutes or so about the areas they are most interested in. Then we'll have at least 15 to 20 minutes for questions from you and general discussions. So, so the contents of the panel, we picked a few topics here to get started. We don't have to confine ourselves to that. If you have other questions, we'll of course discuss them. But the first one is 5G, what they call device-to-device communication. Is also known as side link communication. And it's a very powerful capability that makes possible within 5G devices to actually form a group and talk among themselves, even in the absence of a 5G base station, right? So that's a very, like a MANE, it's only there by themselves. They can talk to each other, and they can talk also when they're under base station coverage, they can talk to, of course, just like a normal 5G device. But it's a very powerful capability, what was introduced in LTE, but never really gained ground. There's no commercial devices. I think release 17 has it, and in standards, but I don't think there's any commercial device out there yet. It'll be a couple of years probably. The second very interesting advanced technology in 5G is, of course, the integrating 5G with satellites, right? And the first step is very, very fundamental, very, very simple, I would say. In release 17, they have what they call it transparent. So that's nothing more than if you have a 5G where there's no base station coverage close by, just like what happened in Hurricane Helene, then of course you can use the satellite network to send texting and so forth. So in this case, the 5G device or smartphone will be just using a satellite to route back to a base station on the ground, right? That's called transparent mode. So that's the starting, but then the next actual integration is when the base station will be located in the sky on a satellite, right? So, and there are a lot of challenges there, we'll talk about them. Then of course in 6G right now, there are a lot of research going on, but the one that we want to talk about is the integrated sensing and communication, ISAC. And that has, you'll see that that's a really revolutionary technology that can then use the base station in addition to communicating with the 5G devices, can actually, using a radar-like waveform, they'll redesign the waveform itself or find a way to do both, actually locate all of the devices and locate other objects that are around the base station. So that's quite revolutionary. So those are the main thing. And of course, wanting to take advantage of Dr. Woodward being here, we want to, of course, hear about, if you have any questions about the FutureG portfolio in DoD, because they are really the leaders in this country from the government of adopting 5G and taking it further. So beyond 5G now, if FutureG with 6G and so forth. So I think I'll stop there and would invite Dr. Woodward. You can speak sitting. I think you have a phone or microphone there, or you can come up here and speak to your slides. So next set of slides, please. That's number 2.
Yes, sir.
Thank you.
Okay, I got to stand up. I can't do
Yeah, here you go, this clicker, and you know it's, I couldn't do a good job of it, but you can.
We'll see how this works. Yeah, sure. So hi, everybody. I'm Ted Woodward. I'm the technical director for the FutureG initiative inside OUSD R&E in DoD. And I'm really happy to be here today and kind of kick off this workshop because I'm interested in learning more from you folks. I warned Arup when he invited me to come here that I was not a security expert and shouldn't try to pretend to be one. And he said, no, that's fine, that's fine. So we'll see. But what I wanted to do was give you a flavor for what we think about when we think about security within the context of the FutureG initiative. So hopefully this gives an interesting framing for some of the discussion that we're gonna have. So it skipped over the second slide, skipped over the slide. I'm just gonna, there it is, yes, great. So the mission of the FutureG initiative is really pretty simple, which is we look at the problem of DoD communication needs. And the DoD's communication needs have continued to grow and expand to the point that we really can no longer afford to go about all on our own. So, roll your own solution is probably not sufficient. So exceeding the capabilities of building our own stuff. So we look, with great interest at the global industry in mobile wireless, which spends, hundreds of billions of dollars a year annually in wireless R&D, and we want to find ways to make that useful to DoD. So that's advancing, adopting, innovating on top of technologies that are out there and do research and development for that purpose. So that's sort of the mission of the enterprise writ large. Now going to the next level there, we want to ask the question, I'm going to be careful with the clicker. There we go. And again, it went too fast. So just, maybe I could just say next slide, please. Next slide?
Yeah, next slide, please.
Gotcha.
Thank you. So this slide is really here just to introduce a couple of concepts. The first concept is the dimensions of security that I'm sure you're all familiar with, confidentiality, integrity, and availability.
that we think about that, then the second thing I want to get across is perspectives. So there's two different perspectives you can take on that problem. One of them is DoD as the user of the network. So I'm using the network and I want to do that safely. And the other, DoD, is the operator or the owner of the network. So we have our own private 5G network. People are using that network and I want to keep it safe. So within that context, we have some familiar territory like, private wireless networks, green radios. DoD has had to worry about managing wireless green radio networks for some time. And there are a couple other familiar territory items that are listed here. And the new territory would be using third-party wireless networks. So if I'm engaging with a wireless network, I want to be able to do that in a confident manner. So for example, NTN that we just heard about, how would I engage with an NTN network that might not be my own? Or that I am the owner and the operator of a private 5G network. So the deployment of a tactical 5G network will also be a little bit new. So having got that framing, then if we go to the next slide, please, we can think about a layered model for transport. So if I think about from the top of the graph where I have diverse users that want a path to access something at the bottom of the slide, networked applications. So this is sort of a protocol stack kind of look from top to bottom. We can think about accessing that through three distinct layers, and some of those layers have a lot in common with other fields, and some of them are unique. So the first one is the PHY layer. So the physical layer, this is the RF interface, air interfaces, new radio waveforms. This shares a lot of security considerations with the domain of electronic warfare. So, I'm interested in geolocation, I'm interested in detection, I'm interested in intercept, and interested in defeating those things. Then there's a second layer, which would be unique, really, to the radio access network. That's the mobility layer. So I'm trying to get access through the PHY layer to assets, and I might do that through a private network, might do that through a public network, or I might do that through a mixed network. So imagine that I'm dealing with an MVNO that's got relationships with public operators. So this is the second slice. And then the third slice, the network itself. So here I've kind of dumped out my traffic into the IP domain, and this is really sharing a lot of concerns with cybersecurity, IP layer security. So we can borrow a lot from that field, which is heavily represented here at this workshop. So within those three slices, then we can see where we might want to focus, our security work. If we go to the next slide, then that allows me to introduce the final level of segmentation, which I thought was an interesting way of thinking about where different security concerns might lie. So now I've taken those three dimensions of security, confidentiality, integrity, and availability, and tried to apply them to these three different layers. So for example, if I just take one of these, the upper left corner in confidentiality, at the PHY layer, I'm worried if I'm a user, I'm worried about LPI, LPD, low probability of intercept, low probability of detection. I'm worried about geolocation in the RF domain. If I'm the operator of a network, I'm concerned about something different. I may be concerned about privacy versus openness in my network operations. If, on the other hand, I might think about, availability concerns, what would an availability consideration be at the mobility layer? Maybe if I'm a user, I'm concerned with degradation of my QoS. I'm not getting the quality of service that I wanted, and I want to ensure that I achieve that. If I have an agreement with an operator for a slice with certain QoS guarantees, I want to see that that happens. If I'm the operator of the network, I'm worried about denial of service attacks on me by others that are preventing me from providing service to my clients. So I thought this was maybe an interesting way of segmenting our portfolio. And then if I go to the next slide, I've applied that to the portfolio of efforts that we have within FutureG. And the first observation is that of the programs that we have, at least 35% or so of them had a security dimension to them. And that I thought was meaningful, so a significant slice of the efforts that we have. Many projects have a security element to them. They may have other elements to them as well. And then if I think about the layer that they're working on, the mobility layer did have, most of the efforts, although not all of the efforts concerned in them. 40% of the efforts had a mobility dimension to them. One thing that stood out to me was that of the efforts that we had that had a security dimension to them, 68% were operator-centric as opposed to user-centric. And I thought that, that was telling me something, perhaps telling me that we might want to put a little more effort into, security at the user layer. And so we could ask questions about the portfolio at that level. What attributes of mobility layer are most important to be thinking about? And then, how could we bring shared areas of interest to bear as effectively as possible? So how can I leverage, say, work going on in cybersecurity into the FutureG domain? How could we leverage electronic warfare? And then what unique efforts would make sense for us to undertake? So if we go to the next slide, then that gives me a chance to talk about a couple of examples within the portfolio. So obviously I'm not going to go through all of them, but just a couple to give you a little bit of a flavor of it. Idaho National Laboratories is one of our collaborators that we work with. Arup just talked a little bit about some of their capabilities. This effort actually encompasses both the user as well as the operator perspective because they have a network that could be used in both ways. So you could pretend this was a DoD network and you have full visibility to everything that's going on. You could also think of it as a third-party network and you could use it to see what happens to the user when they do that. So their capabilities are summarized here a little bit on this slide. They have a cross-functional team that can analyze vulnerabilities. They can do red teaming analysis. And they have a network that consists of exemplar 4G and 5G commercial scale elements, total of 14 radios deployed across their site using core network suppliers that are listed here from Mavenir, as well as picocells, as well as elements from Nokia, all out in the field, and then also a laboratory network where they have a core and several elements that can allow them to explore different performance capabilities. So that's one of the assets that we have in the portfolio. And then if you go to the next slide, talks a little bit about another project that we have going on that's a little bit different from the security standpoint. If you'd back up one, please. I'm glad to see somebody has the same problem that I had with the clicker. Back again, please. One slide back. Great, thank you. This project we call Avoid. So it was coined, back up one more. Try again. So the objective here, really the insight that's being applied is what you formally think of as a black box, and the infrastructure is a black box of a third-party network. You say, no, actually I can look inside the black box and I can see what's in there. And one thing that you might want to know is whether or not that, maybe that works if you just go back one and then just sit there. That might work. So, so the first thing would be, can I identify elements of the RAN? And the answer is yes. If you listen to what the RAN is saying to you, you could characterize whether or not that base station is, who that base station is manufactured by. So using capabilities that they've developed, they could spot whether that was a Nokia or an Ericsson or a Huawei or a Samsung base station. And that ended up being ported to an application that could run on your handset. So you could have, with your handset, an ability to identify who is the manufacturer of this base station that you're looking at. And if you go to the next, if you go back to the previous slide, they were actually able to go even further than that and look inside the network to ask yourself, well, once you've gotten past that RAN element, you're going to go through several, maybe several routers on your way to your destination. You might be concerned about who manufactured those routers. So they also had techniques that could identify those. And then also develop a capability to force the traffic to avoid the routers that you didn't like. So those, of course, are very interesting capabilities, and for full utility, they would need to be packaged into a tool that would automatically allow the user to connect with indigenous networks with greater confidence. So we'll go ahead and go to the next slide, since that seems to be where it wants to go anyway. The folks at CADA, which is the primary performer on this effort, have a live website where they're tracking this result, and this is simply the results of some of their monitoring measurements made at various points in the U.S. And just in case you were wondering, yes, in fact, there are still Huawei base stations deployed in the United States. This is an example of one of them that's been flagged, and that's simply because the rip and replace funding that the FCC has provided has not been fully deployed to retire these elements per the legislation intended to do that. And it's kind of an interesting visualization capability that they have. So that's two examples of the security portfolio from the FutureG effort. If you go to the next slide, which is the close, which is, just to summarize, right? There's a lot of overlap of the FutureG security portfolio with other parts of security, cyber as well as EW. Those are segmentable, as I mentioned, between the user of a network or not. Most of our project investments, at least at this point, have been in operator-based security. I think that's something that we might want to change going forward. And we have a lot of areas of further interest, right? User endpoint tools, like I just mentioned, obfuscation methods, adversarial employment of similar methods. We might be interested in detecting and understanding that. We didn't talk a lot about, our interest in Open RAN, but we do have a significant interest in Open RAN and development of tools and XApps and RApps. Phil will talk a little bit about some of that, I imagine. And I'm really looking forward to learning more from all of you about, the security community and how it can plug into some of the things that we're doing. So with that, I'll turn it back to Arup, and he'll be able to go on to let other panelists have a couple words. Thank you very much.
Thank you. So next we'll go to Phil Porras. Can you bring up the next file, please? Thank you. You can be here.
Don't try the clicker.
Yeah, exactly. So how we're going to do this? I'll just stay on this slide then. Could I ask you to? So hi guys, I'm Phil from SRI. I'm up in the Bay Area and have been there for quite a while. Can we go to the next slide? I'm going to talk about at least my perspective of things.
It's showing here, but it's not showing over the screen. You
Oh.
had the first slide.
Oh, you guys can't see that, huh? All right.
You can go
There you
back
go.
one.
There you go. Okay. I think we're in an interesting time. I think we are dealing with the idea that networking is evolving. Network was evolving about 12 years ago when we were really working with software-defined networks. And software-defined networks have really enabled the kind of modern networking, industrialized cloud applications that we see today. A lot of this evolution just comes. I get really excited around software-defined abstractions. When software-defined networking became an abstraction where you allow developers, security people interested in developing algorithms to be able to integrate into the control plane and stop being in a closed proprietary sort of architecture, you get a lot of innovation very rapidly. I'm not saying that just translates into instant success in the market. It doesn't. It takes time. That happened in the SDN community. And we are seeing, I think, in the mobile community, this movement toward new open architectures, new way for our community to be developing out algorithms that can then be integrated into very interesting locations in a mobile network architecture. In the data plane to do runtime analysis at the edge and understanding how devices communicate with base stations. Inside the control plane so you can manipulate and optimize and look for threats and come up with fault detections of devices as they interact with the base stations as they overall interact with their environment. And then in the core, to be able to optimize and deal with network threats or malicious devices, and then push all of your knowledge back to the edge so you can better handle and better respond. It's a very interesting time. We know that when we start talking about 5G, people are leaning toward the service provider notion, the telco notion, which is where this stuff lives, and we are moving away from this closed proprietary architecture, particularly as we move toward this idea of open radio access networks, the ability for people to standardize APIs, to modularize the development of network functions, of services, of the data plane, and make that also software programmable. This opens up a tremendous lot of opportunity, and we've seen how even in networking, closed proprietary systems lead to lack of innovation. They also lead toward the accumulation of a lot of less sophisticated, the building on top of legacy technologies that are less secure and have led to a lot of problems in telcos. This concept of being able to move toward an open architecture also opens up concepts like 5G to a lot of different use cases. Like those are example use cases potentially that people are talking about for using 5G. So when I think of it, I'm not just thinking about it in terms of how telcos are going to adopt it. I imagine they're going to be very slow. I imagine they're holding on to the golden jewels of what it is they do. They have access to spectrum. They have amazing billing systems that scale globally. These are really unique features. Them migrating very rapidly into Open RAN isn't, in my notion, the success of Open RAN. It's the movement toward an ability to create mobile networks for lots of different applications. And really, it's the application that's going to drive the integration, from my perspective, of things like 5G, things like 6G, things that you want to be able to accomplish that you can't do by tying everything together with an Ethernet cable or using Wi-Fi, and still being able to do scalable, large-scale networking with roaming. That's where this becomes interesting, it becomes exciting, and it becomes, for our community, a really interesting opportunity to be contributing early into the design of secure versions of these architectures. Us coming in late is not a good thing. We ought to be working very closely in parallel with the community as they define out all of these capabilities and apply all of these use cases. Can we go to the next slide? See what's. Oh, okay, yeah. Is that the, just press? Oh, okay, yeah, that's good. So I think there's a lot of opportunities for 6G in security. I think we're seeing, if you look at what people are developing out, a lot of work toward, now if I could see the telemetry of what's happening between devices and base stations and the flow of network traffic, I could start to build these really interesting control services, XApps, or in SDN apps, that you use to analyze in real time what's happening and then develop responses to those sorts of problems to optimize the network. I think that's a really interesting application, and I think AI-empowered networking in 5G is going to continue, obviously, into 6G. I think we're going to double down on that as a capability, something we care about. We care about dynamic control. We care about creating, especially as we move from IP networks, which we understand, for which we have substantial market presence, for which we've built a lot of technologies. Moving to a cellular network is not the same thing as managing an IP network. The skill set that people have for it are going to be much lower. The more we can automate, the more we can help diagnose, the more we can automate responses, the better off those adopters of 5G and 6G are going to be. And by the way, in the previous slide where I was showing you all of those example applications, I don't know that I can go back, so I won't even, can I? All those, okay, I just pressed the red button. All of those all those applications there, all of them are mission critical. There's a business critical, mission critical, safety critical aspect to all those applications of 5G, of 6G. So understanding from our community how we contribute to help them understand how to lock down and secure those networks is very important. What do we mean by network security posture management? Are we going to be able to introduce predictive capabilities to recognize things before they happen and respond to them? Move intelligence all the way down from monitoring at the core to monitoring in the control plane to monitoring at the edge to having smart, intelligent edges, which is kind of the opposite of what you think about when you think about software-defined architectures. You want a simple, fast, efficient data plane with all of the intelligence in the control plane. And then after about 15 minutes, everybody realizes they want to actually push intelligence to the edge. I think we want to push intelligence to the edge as a community. I think a lot of different communities want to push it so that you're doing more processing in very CPU-sensitive environments like the data plane. So you have to balance that. Anomaly detection, enhanced authentication, and privacy. I'll talk a little bit more about privacy in mobile networks, which is something I'm trying to understand what those issues are. And there are issues, certainly. Challenges. With every new technology, you get opportunities to enhance, potentially. Certainly with SDNs, we had that. With radios, we had that. With software-defined vehicles, we're going to find lots of opportunities to do things we want to be able to add in terms of values, but we also find challenges. So what I was just advocating is this idea that, look, expanded use of cellular everywhere. That's a really interesting concept. The idea that we're going to go mobile everywhere. Very cool. But that also exposes us to a lot of expanded adversarial attention. The models ideally need to get better. Our understanding of the ways to exploit these networks are beginning. We are starting to see work come out, releases. I think Youngday is going to talk about some of that work. We're going to present Moby Dojo, and others are going to be talking, and Patrick Trainer's group presenting Ransacked. We are expanding our understanding of the adversarial methods for attacking these networks. That's a fact. Expanded use of these networks, just like expanded use of software, of operating systems, always follows with greater attention by adversaries. Are we ready for that? I don't think so. No. I think we have to get ready. I think we have to continue. It's a continuing problem, and you're never secure when you're dealing with a technology that is continually changing, enhancing, adding features. So we're going to be continually in the battle. The sooner we get into it, the better. The new use cases for 5G as an architecture, is that all being serviced by the telco perspective of 5G and the specifications? Maybe not. There's a lot of very interesting new potential for adversarial attacks, for UAVs, for V2X, for smart factory, et cetera. All of these different use cases for 5G and 6G will produce new adversarial models that we have to be able to deal with. Advanced radio management is really, really cool. Adaptive beamforming, dynamic antennas. I think we're supposed to talk about ISAC, for which I don't know very much about. MIMO optimization, all really cool. All may introduce novel radio attacks. If you develop a new way of managing your radio better, you've created a weird machine that I can then develop out a method for how to exploit that control to do what I need your radio to do instead of what you need your radio to do. That whole aspect of understanding the new capabilities, the new advanced RF management, and how that can be exploited is going to be a really interesting thing for our community to try to understand. Did I skip one? I know everybody else was skipping stuff. Yes. Did I? Oh, God, I can't. So I talked about part two. Hey. Right. I guess I'm an advocate of the idea that the Open RAN architecture and just opening up your mobile networking is an important thing and development that's happening that's creating a lot of exciting opportunities for people to be studying the security aspects of that, developing out security services, a fault modality detection that can help you develop more resilient, more independent radio access networks, particularly at a time where the skill sets of our IT administrators, our operators that don't fully understand how to go through the million pages of 3GPP specifications to know exactly what's happening, that's really drawing a need for communities to develop automated ways of protecting those networks. We see even substantial attack surfaces emerging. We know that when we build things in the cloud with software, that opens up entire attack surfaces. Now we're developing out mobile networking infrastructures that are dependent on those same architectures, Kubernetes, the cloud, APIs that can be exploited, software that's being integrated. Substantial new attack surfaces happen when you open up from proprietary closed systems that are very controlled to open systems where everybody contributes. And everybody contributing technologies into a security makes it very difficult for you to say something about the composition of the security properties of the system that you're trying to develop. New recognition of attacks and an enumeration of over 100 attacks that were recently published is that affect Open RAN technologies, that introduce new CVEs, that recognize problems in the specification. These open attack frameworks, I guess we're going to talk about one later today. Mobile exploit frameworks are exciting to see come out, where our community can be developing out demonstrations of the vulnerabilities that exist within the fundamentals of 4G and 5G and the problems that exist within the software that's being developed there that we need to be able to contribute to help people understand why security is so important and develop out the solutions to help recognize those, prevent those, et cetera. So there's a lot for us to do, I believe. I had mentioned already this idea of low human skills, highly complex networks. Cellular networks are different, challenging, and opening up a lot more capability in terms of functionality with 5G D2D, with ISAC, with other sorts of use cases, with different deployment models, use cases for the technology. All of these create a lot of complexity in how humans handle that. In interacting with people that are trying to deploy private 5G networks, I'm getting a lot of feedback that the infrastructure for doing management, for understanding, is the system that's been deployed secure? Are the devices that are connected to it the ones I expect to be connected to it? Are any of them in trouble? Is there anything in my RF perimeter that I need to know about? Is my base station happy? Is it experiencing anything? Those sorts of tool sets are things we need to really work on and enhance. We need the equivalent of the kinds of technologies that we have for IP networks in this space. We need it in the core. We need it in the edge. We need to develop out new capabilities here. We also have to define out what our notions of secure configurations of these things look like. When we deploy for a smart city a 5G network, when we deploy a private truck 5G in an enterprise, how do we think about locking down all of the software, providing least permissive controls over who's allowed to interact, et cetera? There's work going on right now in the open source community. The Open RAN community has, for example, the NEFIO community. The NEFIO community is developing out notions, and others are too, of blueprints. The idea that when I instantiate and automate the instantiation of 5G networks, I automate with it the instantiation of security policies that will enforce the least permissive controls over those network services and functions that need to interact in that environment, to help reduce lateral attacks, to help reduce exposure of vulnerabilities that are going to be inherent in all of the libraries. Open source has vulnerabilities. We need to be able to reduce those, recognize them, monitor them in runtime, and ideally prevent them by locking down in a least permissive way the ability for those applications to operate. We need to be able to deploy and maintain. These are all challenges for us to think through, and there are groups that I'm aware of that are working on all of these different problems. I was going to have a last comment about privacy. What do we mean by privacy in 5G and beyond networks? I don't know. Do you feel like when you connect to a wireless network, 5G network, 4G network, that you're in control of that communication that your device that you own has with the radio access network? You don't have that control. Your network usage, whether you transmit or not, is that part of what we mean by your control and by your privacy? Because you don't have that now. You're not likely to have it. Your identity, your geolocation, and geoprivacy, are those things that should be considered in this realm of things we want to provide? Maybe for some applications that becomes important. Right now, do we really have that? Do we consider that part of the privacy scope for people that are going to be working in the future of 5G and 6G? Your content, your activities. I don't think we get a lot of these today. I'm not sure the things are going to improve as we move on from 5G to 6G. Understanding what your exposure is, who has control of what control you have on these devices is a really interesting question. I don't know really how to define a nice, crisp way of saying this is 5G privacy, because I don't know that you have much. What does it mean for 6G? And as we develop out these new applications, these are, for different environments, going to be really interesting questions to try to answer. I'm not working on that problem. I hope somebody is. Oh. Yeah, I don't think I'm going to talk about all the wonderful things that are happening in space. I'll just stop right there, take a break, and I guess we'll move on to the next panelist.
Phil, but let me say, I think this subscriber identity, right? Now 5G does have a way to hide it, right? In 4G it was not hidden.
Suki, right? There's no way to geotrack Sukis, right?
Right. So I just want to.
There's papers published that describe what we mean by geoprivacy. That Suki is supposed to defend against. There are vulnerabilities that we know about. So, do we bring these up to the 3GPP about the fact that individuals can be tracked even when you have anonymity in 5G? Yes, we do. What are their thoughts? It haven't been solved yet. Do we really, when it comes to geoprivacy in 5G, is geo-privacy a bulk thing, like what you had in 3G and 4G, the ability to monitor large numbers of devices? Or is it something that each individual has some control
There are still
over?
questions
Well,
to
I
be.
don't know.
Yeah.
I don't know
So,
that we've
yeah.
solved it in 5G.
Yeah, right. I think we have made steps, and every release when it comes out, 5G did a really good job in having the security, most of the security improvements, including the encrypting the subscriber ID. And then also for roaming. Roaming was very insecure. There are a lot of attacks through the SS7 networks. Roaming had considerable improvement, which is DoD or OUSD actually, and their partners are using very actively right now. So okay, let me stop and let invite Don McBride here. Don, your thoughts on securities?
Thank you. Thank you, program team, for inviting me, and thank you all for coming today. I'm going to keep mine real short. I didn't prepare anything. I want to give a couple of examples of what we're researching, and also just let you know that in the areas of confidentiality, integrity, and availability, we've probably got at least 10 projects in each one of those areas. So there's a lot of work going on. I'm going to try to give you two ends of the spectrum here. First of all, leveraging on what you were talking about, Phil, with some of the concerns going on with the geolocation information sharing. We've been studying privacy as it's been impacted by lack of confidentiality and integrity protection at the MAC layer of the RAN. And there's several good papers that we're reviewing regarding attacks, and we're doing threat and risk analysis and trying to ascertain the impact to customers, operators that is, and to end users, and to determine where are we getting a bang for our buck. Nokia isn't like the old Bell Labs. By the way, we're celebrating our 100-year anniversary this year, so I'd like to put a little commercial out for that. Please check our website out. It's got some great history there. But we're a business, and we have to prove that the research and the development that we put into it is going to be worthwhile. There is a very little budget for exploratory and investigations, but for the most part, we have to prove that what we're doing is going to be worth it. So we're studying these attacks, and we're able to understand the impact, and we're able to understand the development costs that will be required to fulfill this. But we're not really sure exactly what the customer wants. The customers are really not asking for this. And so that's, to us, that's the X factor. What are the customers wanting? They would prefer, of course, to have these features in, but they're not really pushing them in standards and so forth. And it's impossible to really get these features into our program without it, of course, going through standards. And there's a certain amount of disagreement with respect to other vendors and customers about what the priority is and exactly how to resolve these problems. So that process of going through, doing the risk analysis, understanding exactly what needs to be done in terms of development, sharing that with our standards organizations, having that proposed to standards, getting feedback from operators, getting feedback from other vendors, iterating on that. That's a very long and arduous process. And we continue to look at new and add new attacks to these all the time. So we kind of build this portfolio, build this business case, if you will, of whether we should go ahead and actually implement these new features that will protect the MAC layer, or do we just fly with what we have? So yeah, that's on the small scale, very minutia, but important. So that's sort of one end of the spectrum. The other end of the spectrum is really future networks. And they're driven, again, by customers. What are some of the complaints that customers give us? Today, their networks are just too complicated. There's so much complexity for for configuration, for provisioning, integration, and they're error prone because of this. So what they're looking for is automation, autonomous services, predictive services, if you will. They're looking for a way to isolate heterogeneity. There's so many different kinds of platforms, operating systems that they're running in a network today. They can't keep track of it. It's just too complex. There's a scalability issue. Can they grow these networks on demand, and can they reduce them when they want to? They don't want to be powering things up if they don't need to. There's a very severe concern about sustainability and efficient energy usage, so you need to be able to recognize your demand and be able to adapt to it. Yeah, and then of course, do all this and be secure. So these are, all these demands are upon us, and we're trying to determine how do we fulfill this. I mean, we've got, as already been mentioned here, a number of initiatives going on, and we've kind of combined our research efforts and formulated a big picture network we're calling UNEXT. That's U-N-E-X-T. It stands for Unified Network Experience. And it's the creation of an ecosystem where applications can demand resources from this UNEXT network and provide an intent to the network, and then fulfilling that intent with an intent-based architecture. We basically go out and negotiate for those resources in a ecosystem where we're using resources from the domain that's native to whoever received that request, or cross domains to other domains, and negotiating through what we'd call a gateway. And so that's presenting some very interesting solutions, and we are very optimistic, and really this is the cornerstone of our research right now. It's what we call a big bet in Nokia. We expect this to be part of our story going forward as far as the future research we're doing in terms of mobility, but also other projects we're working on, such as a mining application we're doing. This UNEXT big bet really encompasses many of our initiatives and brings them all together. So yeah, that's pretty much all I want to say at this point. I look forward to hearing what all of you want to talk about. We've got, again, a number of projects at Nokia that we're doing that have many of the details that were already discussed today, so let's get to it. Thanks.
Thank you, Don. Thank you, Don. And let's see now. Let's take a pause here, and I think, do you have any questions in your mind that you want to the panelists to address at this point? Okay. So what I'll do, I'll let you think about it. Yeah? Yes, please.
Okay, thank you so much for the interesting presentation. Can you come to the microphone, please? Oh, here it is. Okay, one right there. Yeah, I see it. It's hiding.
Yeah, it's hiding.
First of all, thank you so much for the nice presentation. So I heard multiple times that we like openness and Open RAN, and we would like to open the networks for innovation. But the more we open things, the more vulnerable things become, right? Yeah. So the question here is, how much openness do we need, and how much do we want to really balance this trade-off between security and, innovation? So I would like to hear your thoughts on this.
Great question. I think Phil talked about it a little bit already, so I'll let you start, and Ed, you join if you want.
That's an excellent observation that open architecture, software-defined architectures open up both opportunities for us to innovate, to create, for example, in the security community, security applications, to build in tools that can work and analyze and do things like monitor or lockdown, prevent, detect. They also open up attack surfaces. We are now inheriting on top of our mobile network architecture in many cases, cloud-based APIs and a lot of open source libraries and Kubernetes. And there are substantial attack surfaces that come from everything that we're adding in. We're adding in, at the base station and with the protocols that you use, attack surfaces that, and we have software that basically runs at the edge. Those introduce these vulnerabilities. Can the services that we add actually lead to a net positive over the attack surfaces that we expose? We try to create open standards that consider all of these, that consider very early on things like zero trust architectures for how we're going to lock things down. The more we do that, the more we think about APIs and the vulnerabilities that get introduced, the sooner that we're able to consider developing out a definition of a secure configuration, a secure instantiation, and we develop the services the way we are able to add in security operators in ways that solve or complement each other in protecting. Ideally, you lead yourself to a net positive. The openness that you have, the attack surfaces that you expose are reduced, they're recognized, and they are, over time, compensated with security services that allow you to do things that you weren't able to do before. That's the ideal case. It takes time to get there, and it takes a lot of thought and a lot of recognition. I'd also mentioned that there was a community of people that are trying to develop cellular attacks and demonstrating vulnerabilities, helping us recognize what the threat is, trying to convince this recognition that we're not getting a lot of call for security. You may not get that. Security calls seem to come in spikes when Salt Typhoon hits, or when you have a major attack vulnerability that occurs, when a CVE gets exercised, then you start to get a real recognition for it. So that doesn't stop us from innovating. It doesn't stop us from working to try to recognize what those attack surfaces are, develop out as many open examples of those as possible. They're not proprietary, they're not hidden, they're not just known to the black community. They're known to the security community that is sharing them, not just with industry, but with everyone, including governments that can actually put some I don't want to say pressure, but put some recognition to those companies that they really should be dealing with these issues. It's it's an ecosystem that we faced. We faced it with software-defined networks as well. But it's a good observation. Yes, every time you open up, you open up an architecture that allow people to innovate, you open up opportunity and challenges, and the balance between those two hopefully skews toward, or there isn't a balance, it skews toward security in the long term.
Thanks, Bill. Dad, you want to join?
I actually think it'll be much more helpful to people if the experts talk first. So I'm going to let Don go first.
Yeah. Thank you. I'm going to step away from this before the feedback comes. I would just like to say that with openness, you achieve openness through standards. Standards are agreed upon by basically allowing variation. Variation brings in problems in deployments where you have incompatibility. And then you have these complexities and these troubles that features are not working. Phil, your point back that you mentioned of blueprints, we found that taking some of that variability out and identifying profiles or blueprints, if you will, that are followed, give it a little bit more structure, a little more deterministic configurations, and really helps security a long ways. Not just security, it's many features, but security in particular gets a lot of attention. So openness in its nature, yes, creates the variability that causes troubles in security, and providing some level of compromise to that where you have different blueprints to choose from, but standardized to the point where you can make your network follow those and you can audit them and assure that, yes, we're following that and we're confident that the securities acts have been implemented correctly.
Yeah, I guess the only remark I could add to this would be that openness has a lot of value from the user system perspective. I mean, we in DoD see Open RAN as a very valuable capability because it gives you modularity and interoperability. And without that modularity, there's no ability to customize. So I can't take something out, put something else in to do what I want. So then you're faced with the question of given that I want that, how can I get that in a secure manner? So a way to reflect on that, I suppose, would be to say the security vulnerability, there would be nothing to prevent a closed, non-modular system from having a given security vulnerability, right? That you could also have in the open interoperable system, you could have the same security vulnerability. The question is, does everyone get to see it, or do only a few people get to see it? And do you believe then in the long run that it's better to have more people see it than not? So that gets to your philosophy of, are there more good people in the world or more bad people in the world? And I'll leave that for you to consider. So I think the results of some of the successful open source projects in terms of how quickly bugs get identified, how quickly they get fixed, would lead you to the conclusion that open is probably long-term better.
Awesome. I think it's a difficult question to answer, but I think the answers are really what people are looking for, that the good will outweigh the bad. And as that says, the more we know about these issues, I think it's better off anyway. So any other questions, please?
So I have a quick comment on the openness.
Yeah, sure.
So I think the specification is open anyway, right? So I think having open source implementation is great, actually. Will improve the security. And I think more proprietary implementations actually is bad for security from my perspective. And I have another question. So it seems that US is pushing ORAN, Open RAN, big time.
Yes.
But it seems the rest of the world is not a big fan of Open RAN. What do you think about the future of the Open RAN? How you reconcile with the 3GPP and GSMA, and what's the future of the Open RAN? What do you think?
Really good question. Who wants to go first? Yeah. Okay, Phil.
No, I guess I get to cop out because I can think long term, right? As a researcher, you can think 10 years from now. And I think I had a bullet up there that, look, we're going to retire wired networking in the next 10 to 15 years. And a couple of predictions. One is, once you open up the design of systems, which, by the way, is a security principle, TCP minimization is a security principle. Modularity is a security principle. Open design is a security principle. So I agree with all of you that open design is actually a fundamental security principle as much as modularity and TCP minimization. So you need that. In terms of the favor toward ORAN, there's definitely an initiative inside the United States to, inside the US government as part of the CHIPS and Science Act, to stimulate the development of open, secure standards and reference implementations of wireless technologies to make them available such that we can have a market of people that are developing out and commercializing and integrating together technologies to create an overall better and more widely available set of use cases for 5G. It's definitely happening. The principles that are going to probably stick around will be the idea that we're moving away from closed network architectures, from closed radios, to closed mobile networking. This, I don't want to call it a genie, but we've opened up this notion and we're not going to go back. 10 to 15 years, we're not going to suddenly discover the virtue of closed, proprietary, nobody touch it, nobody knows what's inside, networking the way we used to in the area of 4G, 5G, 6G. We're going to have this with us, and taking full advantage of it is definitely the way to go. The desire for people to want to create more autonomous networking and open up AI and create a lot of innovative applications that are better at sensing, better at responding, better at explaining to unsophisticated cellular network operators what's happening so they can respond quickly. That's going to be a major part of the selling capability. Whether it's Open RAN, whether 3GPP is leading it in the context of maybe telcos where they spend a lot of their time pushing the technologies versus Smart Factory versus V2X, do they have the same perspective in providing specifications and standards that are going to really work for other uses of mobile wireless networking? I think we're to see if that really does make sense, or should there be communities of people that really want to use 5G, 6G, and beyond for municipal, for Smart Factory, for V2X, and create variations of the standard that really address and lock down and minimize what's necessary for that technology, for those applications to work, is to be seen. So will we have, in 10 to 15 years, a generalized O-RAN that works for everybody? Even within the US? Unclear. But I guess the thing I would have more confidence in is that once you open up control planes and data cores and data planes for a lot of people to contribute innovative ideas in AI, you're probably not going to be going back.
Excellent. So I think we'll certainly have to listen to Dr. Woodward, because as part of DoD, the first NTIA, the Open RAN Challenge, you were the leader of that, right? You had worked with NTIA to have that. Remember Open 5G Challenge that started the Open? You'll hear from Don also, but I want to hear.
Yeah, how could I forget? Yes, the 5G Challenge was one of the initiatives that we had within the FutureG team to try to foster open RAN networks. And I think a lot of the observations that Phil is making are very germane here, which is that through the proliferation of open networks, you're going to have more innovation and more people able to contribute. And from that, you'll get, more value and more utility. So I think that this is a good point to consider. The question is how fast, right? So as you said, right, how fast does this happen? And if you want that innovation, it comes with the requirement that somebody has to figure out how to put it all together. So how do we get the interoperability? Who's going to integrate the system? Who's going to who's the one neck to grab, so to speak, when my network is in trouble and it consists of a multi-vendor collection of parts? So these are all practical considerations that I think have to get addressed, but they also will create opportunities in the industry for the emergence of new classes to be able to address some of these problems. So, I think the general trend is fairly clear. The question is really, when does this happen and how quickly does it take hold?
Yeah, I also thought that the question, I think we do need to acknowledge the fact that this is certainly priority for US because of lack of US-based vendors in the radio network, right? And I think Open RAN architecture allows vendors to create just the radio unit, just the radio or the CU and DU. And so I think I think that was a big driver in this country as compared to other countries, why there has been a push or the public availability of funding in the CHIPS Act to create more U.S.-based vendors, right? Is that, I think I'm correct in that?
I think you can take this question out of the question of domestic or international economics, right, and just look at it from the standpoint of, do you want the most effective network regardless of who's supplying it to you? Sure. And so I wouldn't fall back on the argument that says, okay, well, so this is a U.S. initiative because they want to do things for U.S. industry. I think regardless of where somebody's going to buy their network, they're going to get benefit from an open, modular, interoperable solution, sure, regardless of who builds it.
Okay, thank you. And Don, you want to add your thoughts on that?
Hello? Are there any U.S. vendors? I'm just wondering about that. I don't think there are. Nokia is as close as you're going to get, I think. To your point about the the CHIPS Act, we're participating in that right now. So I can certainly vouch for that. I do know that there's a lot of activity in Open RAN within our organization in Europe. So I wouldn't say that, to me, it's never come across that it's lopsided one side or the other. But there's inertia.
Right.
I've seen development analysis of the work and the options of how to divide the CU, the DU, the RU. What's the best way to move forward architecturally? It's not trivial. There's pros and cons with every option. So, yeah, and we don't want to make a mistake. Mistakes are very costly. So there's reluctance to move forward. And until that need becomes obvious, that reluctance is going to cause delays.
Just add one more thought, and this comes from the lunch conversation I had with Youngdae, who asked the question, which was, if it were the case that the United States went in a particular direction and brought forward Open RAN and really developed a lot of industry around it and developed a lot of use cases, but the rest of the world wasn't doing that, would that be a precedent? Would that be something like unusual? I don't know. I think the U.S. really embraced public cloud. The U.S. really embraced and really created these really trillion-dollar industries around the way we now architect industrial software, which is through virtualization and then the deployment in third-party infrastructure and infrastructure cloud as a service isn't something that's globally used. Every country out there isn't on Amazon or have that same notion of wanting to push their business software, the software that interacts with their customers, out into a public cloud. It's very big in the United States. It's not big everywhere else. It's big in certain places, but there are countries that really, their businesses don't revolve around the cloud the way it is embraced in the United States. Will the US develop out an industry that is really depending on 5G for municipal and smart factory and V2X? Maybe. Those may come to pass over time. And will that be a hindrance if it's not developed in the EU, it's not developed in Asia, it's not developed elsewhere? Not necessarily. So is it possible that the investment in Open RAN will pay off with Open RAN success in the United States that doesn't really bleed out across the world? I don't know, because in telco world, everything, and in communications and mobile networking, so much of it is international. Like you said, is there a US-based vendor that's supplying this? It's such an international endeavor that's not happening in the US, and yet the US is trying to push this direction. So I don't know. It's a really interesting question, Youngdae.
So yeah, thank you for that question. With that, I think we have come to the end of the hour, so we'll stop here. But let me, please join me in giving a round of applause to the panelists. Thank you.
So that's all about the panel. So next we are going to start the paper session. So thanks once again to the panelists. All right, so our first session is about AI-assisted NextG. We'll have 2 papers to be presented, and then we'll have the break. The first paper is AI-assisted RF fingerprinting for identification of user devices in 5G and FutureG, and it will be presented by Osheria from Florida Atlantic University.
Hi everyone, I'm Arupjyoti from Florida Atlantic University. I'm here to present our paper on AI-assisted radio frequency fingerprinting for identifying user devices on 5G and FutureG networks. This research is essentially my master's thesis research, and this paper was one of the products of that. Guided by Dr. George Sklimanitis, Dr. Pattis, and Dr. Bentley from the Air Force Research Laboratory. Just a quick disclaimer before we get into it. Just because of the nature of the grant, we'd just like to specify that any conclusions and findings presented in this presentation and this paper belong solely to the authors, and they do not reflect on the Air Force Research Lab or the US government. So 5G networks have definitely been a game changer for connectivity, especially with respect to IoT, with FutureG coming around, promising an even greater degree of connectedness and support for more devices, and the general openness of it all. It's important to recognize the threat of device impersonation, which is basically one of the ways that an adversarial party can gain access, unauthorized access into a network. So the security approach to mitigate this would be to take the route of having physical layer authentication. It's basically because, well, in the past, this has not been possible with rigid structures of radio access networks, how they were, but with the progression towards FutureG and modularizing everything and disaggregating components and just the general openness of it all, this would be an ideal time to be able to customize designs going forward to be able to actually implement that. So to understand this threat a little bit, I'll just briefly kind of go through the current state of 5G authentication. I know the SUKI is concealed, but just bear with me for the sake of the argument. Essentially, what happens is when a UE wants to join a network, it'll send over some credentials. They're usually concealed. This will go to the G node B, which will communicate with the backend, pass this on all the way down to the UDM, pull up sort of a challenge for the UE to solve, and then it would know the right answer. The G node B would send this challenge back to the UE or UD, and if the response from the UE matches what the G node B is expecting, it'll go on to authorize the device to access the network. Now, so the credentials and I guess this credential-based authentication process does have a couple of vulnerabilities to it. Namely that, well, credentials can be stolen. You can do that through SIM cloning, just stealing SIM cards, malware attacks, fake base stations, man-in-the-middle attacks, and that's just to name a few. There's many ways. So all this to say, with this entire process focusing around credentials as a whole, there's really no way between all these exchanges to really, answer the question, do these credentials even belong to the device that we expect them to belong to, which is why there's this imperative need for a physical layer of security that operates fully independent of any authentication credentials that are used in this process. It's independent of any signaling characteristics that are only specific to 5G or later on 6G and so on in the future, and it can also be generalized and robust enough to apply across really any environment that it would need to be applied to, any base station that you would seek to apply it to. So in our experiment, or in our research rather, the method that we chose to implement this through is by doing radio frequency fingerprinting. So whenever any components or machines are designed and manufactured, even if they're designed to be identical, no two things will ever fully be identical in practicality, just because during the manufacturing process, there will always be some minute deficiencies. So RFF is basically the process of using those minute deficiencies and the signatures that they leave in the way a device would transmit signals, and basically use those little signatures to identify or establish a device's true physical identity. So to bridge the gap between theory and practicality, it has a couple of challenges that it needs to overcome to be a successful method. Namely, being able to actually zero in on these hardware impairments that establish identity and being able to isolate them from channel effects, frequency offsets, any external environmental factors and such. And also the effect, the next day effect essentially, which is what says that when you have radio frequency models trained on a certain day's data, you'll actually see the performance of those models degrade over time if they're not retrained like pretty much every day. Apart from that, there's also just challenges with general AI implementation. So you would obviously require very large data sets, which are not readily available at this point, especially with 5G data. And of course, just figuring out other challenges with pre-processing signals. So for our experiment, we ended up using 5G IQ data collected from the Powder platform at the University of Utah campus in Salt Lake City. So they collected this data from their in-house testbed, and it was for a similar study of identifying 5G devices. And the way we used it is that we used IQ data from 4 of their SDRs that are set up to act as UEs that all communicate to a central SDR, that's the G node B. And essentially, these UEs will send several million IQ points of consecutive data over 2 days to evaluate and train models. So once we have that data, we went ahead and added one variable to our experiment called packet sizes. So, excuse me, based on what we knew of the frequency, sampling frequency, and a data frame being about 10 milliseconds long for a 5G transmission, we were able to tell that one full data frame would contain 76,900 samples approximately. So we refer to that as a full resolution data frame. And then you'll see the other packet sizes following. Those are 50%, 10%, 5%, and 1% respectively of a whole data frame. And we created 5 different versions of all our IQ data sets in each of these packet sizes. And then we went a step further, and we took all those data sets in each different packet size and created 2 different representations. So the first one being an IQ slice, just using numerical data of the IQ values, and the second being channel-independent spectrograms. So this was done by doing a short time Fourier transform of the IQ data and then dividing channel values with its preceding channel values to essentially cancel out any channel effects. And with all these combinations of our input data and packet sizes and representations, we decided to put it to test to see how it would work with neural network models that in related literature are known to be suitable for radio frequency fingerprinting. So we started off this experiment with just doing a direct classification of each of these devices. And then just to establish context around like whether any of these inputs actually are even compatible with any of these neural networks to be able to pick out those discerning features that we're looking for. From there, we arrive at the, I guess, main structure and the main point of our experiment here. So this is where we repurpose all those device classification neural networks into feature extractors that actually, this time instead of a one-hot encoding output, they would output a 512 element vector of a fingerprint. And we use this with triplet network training. So I'm not sure how familiar we are with that in the room, but it's basically where you would have device packets from, IQ packets from, say, device 1 that you want to train for, and then your positive would be IQ packets from the same device to show likeness, and then you would have IQ packets from a totally different device to show differences, and then you would converge into a margin where you basically have all the likenesses within a certain margin and all the differences outside. With that, once we have a trained RFF extractor, feature extractor, we're able to plug that into sort of an ad hoc authentication process that we can use this for. So it starts off with enrollment. First, we have IQ data from a set of trusted or authorized devices on our network. We run them through the trained RFF extractor to get a set of authorized radio fingerprints that we use to train our KNN model. And once we have a trained KNN model, we can put that towards rogue device detection and device classification through distance anomaly detection, where basically for any unknown device, it would take its IQ data, turn it into a fingerprint, and then look for neighbors of that fingerprint. If, say, it doesn't find enough trusted neighbors of that fingerprint, it would flag that as a rogue device. And then just applying simple KNN classification just to be able to fit those into clusters when it knows it has a trusted device and identify it as either device 1, 2, and so forth. So our findings from the study, from the first part of the study where we're only using these as direct classifiers, showed that there's definitely a clear preference with the neural networks with higher resolution data or bigger packet sizes. And spectrograms generally do tend to get accepted better than slice data, especially by LSTMs and transformers, just because of, I guess, the amount of compute power they would require to process that. When we look into the second part of the study where we convert these into a radio fingerprint extractor, we see that it's basically the same performance, just a little bit better, and ResNet emerges as, I guess, the clear winner when it comes to device classification and rogue detection. Excuse me. Transformers and LSTMs still, I guess, at this stage, when they can accept an input of that size, they do perform better with a spectrogram as opposed to a slice, but they also can't really parallel ResNets with the combinations of inputs that we've tried. In context of the next day effect, so to experiment with this in our paper, we basically had the enrollment and the training for the entire structure of fingerprint extraction done with day 1 data, and had it pick out rogue devices and classified devices with day 2 data. And I guess to kind of summarize on this, basically, if you have large packets and the input is spectrograms, you're able to eliminate next day effect. You can kind of see that ResNets definitely are a little bit better at mitigating this than the other neural networks. So we know as a conclusion that ResNets plus spectrograms, especially with larger resolutions, are the ideal candidate going forward for RFF generation. Just because we've had a lot better luck with spectrogram inputs as opposed to slices, this also lends this idea that the device deficiencies or impairments that we're looking for to base these fingerprints on, they likely lie in the frequency domain as opposed to the time domain. And channel isolation, or our attempt at channel isolation, is effective in bringing those out as well. So what this all put together means for FutureG is basically just having your training and inference and authentication being modularized this way in a physical layer of security, or potential for that, is something that can be carried into this modular cloud-based architecture that we're looking to implement in the future. This can go as far as, similar to a UDM that stores device credentials or subscriber information. You can have a database for radio fingerprints of authorized devices that's continually accessed and updated as you enroll new trusted devices. And if we need a path forward for implementing that, it's definitely doable by separating these functions out over XApps and DApps and employing that or deploying that with a RAN intelligent controller. So the future work that I'm currently looking into as part of my thesis, as well as my team, is definitely want to recreate this experiment with data from real 5G devices as opposed to SDRs, which is a lot harder to come by. So we're currently working with AirPaw and Powder again, so we can diversify our IQ database to experiment with. And in addition to that, we can also look into trying other input representations like constellations or different packet sizes and fine-tuning our neural networks. Our end goal really is to be able to get a point where we can create our own ORAN GNB and actually simulate this rogue device scenario and have it detect rogue devices and use that towards federated learning to be able to spread that to different GNBs if there were more than one. So thank you, everyone. And that's my talk. I'll open the floor for questions.
Time for question. Just one quick question.
Yeah, sure.
Quick question. Did you test it with the mobility when you move the SDR devices, whether the physical fingerprint stays the same?
We actually have, that's our next step with our data collection with AirPaw. They're actually testing that out with moving user devices. So
I think the physical characteristics will change.
for sure. I think we're expecting to see Doppler effect and whatnot to play a big part in that. But yeah, that's our future work.
All right, let's thank the speaker again. So now the second talk will be presented by Keith. Okay. It is about LLM-assisted vulnerability detection and repair for 5G UE implementation. Yes.
Okay, I can start. Yeah, thanks for the introduction. My name is Ke Yangu. I'm from University at Buffalo. Today I want to introduce our ongoing work, basically a short paper, towards large language model-assisted vulnerability detection and repair for open source 5G UE implementations. Thanks for the authors from Buffalo and also from the Texas A&M University. Okay. Oh, well, everyone knows 5G here, definitely even better than me. So 5G is widely used in many, many scenarios, like especially for industries. And you can say like a smartphone, like a smart vehicle, smart city, even those emails, anything. But the thing is like 5G actually is not really a security thing. It's just a protocol, not specifically for security. The thing here is like there are still some existing security risks, especially when we discuss those UEs, exactly when user devices communicate to the internet, it will explore to some unprotected messages. All right? So here, in this work, we want to focus on this problem. So we want to know how to secure 5G UE user equipment. Actually, for 5G vulnerabilities, majorly we have two kinds of vulnerabilities. One thing is about the design flaws. So for design flaws, there are already many formal analysis methods which can be used to detect those design flaws. But the thing here is like they cannot be really used to guarantee those secure implementation. So for this side, for implementation side, we have the current popular methods majorly are fuzzing or some black box testing methods. Well, the thing here is like they are black boxed. They are not really use those open source knowledge. For example, we have OpenAI, we have SUSRAN or Open 5Gs. So because of that, they are limited with efficiency and some coverage. So by utilizing those open source things, we know there are many analysis tools. Like, for example, the QL, they can help us analyze those developers' codes, right? But they are general purpose used. not really customized and optimized for 5G. They do not know the protocol thing. That's why we need a method to secure open source 5G implementation. Well, someone may say, oh, how about large language models? Because there are two reasons. First, we know many works already use large language models to implement some software vulnerability detection and patching, and also some works already prove they have achieved very good results. They can really detect those vulnerabilities in traditional, softwares. And another thing is one recent research demonstrated that large language models such as ChatGPT, they already be trained with some 5G protocols. They already know some 5G standards and also some 3GPP specifications. So how about we directly use this to solve open source 5G UE implementation security thing? Well, the answer is not really that thing. We can not really directly use that. And we do some tests, we found that we still need some different methods. So here comes two research questions we have. First, how can we effectively leverage those large language models to detect those complex vulnerabilities in open source 5G UE implementations? And after detection, we also want to see if we can really use them to automate repair those vulnerabilities. In our ongoing work, we have a preliminary approach. So basically, there are three major components. One is the 5G vulnerability properties. These come from some existing testing results or some reports. Besides that, we need some 5G specific secure coding practice. We all know that security coding practice are some standards used for developers to write their code. They need to follow some standards. But the thing here, for 5G, we have none of them. We need to customize some new standards to help the developers work on those 5G specific things. And the last part is the chain of thought reasoning prompt. Basically, we want the model performs like some experts, analyze those vulnerabilities like experts doing. So here we use chain of thought reasoning to step-by-step guide the model think like us. One example here, what are those vulnerability properties? Basically, there are some security weaknesses we already find it in 5G UE implementations. Here is one example, because of there's one vulnerability is lack of AS_N.1 input validation, which allows some malformed messages. And there are some exploitable input, security impact, and it may cause some exploitability. The other side, for the 5G security coding practice, we have none. So according with those VP vulnerability properties, we customize some SCPs based on that. You can see example here. We do this, perform validation on all AS_N.1 messages to detect malformed packets before processing the message. Well, with those things, we have some reasoning process. We have this a little bit comprehensive prompt, but you can see basically it's like what we are doing. We first check if the VP is really there. And if it is there, we analyze it from some perspectives. We do some semantic analysis. And then if indeed a vulnerability exists there, we want the model help us to locate the specific code. Similar thing for the repair. It's a little bit comprehensive, but the thing is with those vulnerabilities, we need to step by step to fix that code, right, to avoid that vulnerability. Actually, in our work, we use this sample VP and SCP. We conduct a case study. So this is the case study. We use this OpenAI interface code. We use their code to scan that VP first, and we use our method to locate that vulnerable code there. So you can see with that code, the large language model located that code, and we verify it with 5G Hall, the test platform, and we customize some unprotected message, and it indeed caused that crash, like the rare part. And then we check the repairing. So you can see the model repaired that code with adding those verifications. And then we also test it again. You can see right now the crash just gone. Because it's ongoing work, so currently we are working on 3 different major things. The first thing is like, right now we do not have a benchmark data set. We want to benchmark this kind of measurements. So we want a benchmarking vulnerability analysis in 5G UE implementation. We want to collect more data and do comprehensive analysis. Then we want to automate the process of 5G vulnerability property extraction as well as the SCP creation. Besides that, we want to further expand this work because 5G system ecosystem is very broad. We don't want to just focus on this 5G UE open source implementation. We want to expand it. Basically that's what we did for now. Thanks for Qiqing's slide. And because it's ongoing work, he's happy to discuss more things. If you are interested, just email him. Thank you.